Self-driving is considered to be the next breakthrough advancement in the forthcoming world. As per World Health Organization reports, due to road traffic crashes, over 1.35 million people lose their lives and 20 to 50 million people suffer from non-fatal injuries per year. More than 70% of road accidents are because of vulnerable drivers and pedestrians. Hence, the focus on building self-driving vehicles is sharpened day by day. Beginning of the 21st century is the major turning point of this discipline. People started to get interested in this scenario, more technologies came into play, renowned universities and many reputed companies started investing in wide ranges of research in this field. In consequence, the past 20 years happen to be the glowing years for self-driving vehicles. In the process of building a Level 4 self-driving car, this project addresses dynamic object detection, tracking and trajectory prediction tasks under visual perception. The project provides a complete end-to-end pipeline which performs these tasks in real time. The proposed pipeline takes image data and LiDAR data which goes through the pre-processing stage first. Then its results are used to perform detection tasks which are followed by tracking and prediction tasks at the respective stages. Then the results are visualized at the final stage of the pipeline and the tracking results are passed to the next frame for the continuation of the tracking task. The complete system is implemented on Robot Operating System. 3 separate ROSE nodes are created for sensor data publishing, dynamic object detection, and tracking and trajectory prediction. ROSE topics are used to exchange data between nodes. The sensor data publisher node publishes the synchronized feed of camera and LiDAR data. The published data is accessed by other nodes subscribing to the relevant ROSE topic. The sensor data publisher node is configured to publish data from the kitted dataset, however the node can be easily modified to publish data from real hardware sensors. The subscriber publisher mechanism between the ROSE nodes allows detection and prediction nodes to function irrespective of whether the data is coming from the real hardware sensors or from a dataset. In detection and tracking node, the task of detecting the dynamic objects and tracking their motion through frames is performed. In this node, the center track algorithm has been implemented along with modifications to incorporate LiDAR data to increase the object location accuracy. Here 3 main dynamic object classes are detected using image and LiDAR data as inputs. The detected object classes are cars, cyclists and pedestrians. The mean average precision for car class is 77.9% and the multi-object tracking accuracy is 89.4%. The dynamic objects are demarcated using 3D bounding boxes around them so the drive can have clear visual perception. The track IDs are used to identify and track each of the dynamic objects separately. Trajectory prediction is the defining task for a vehicle in motion. It provides a sense of other vehicles' behavior in order to plan the maneuver. The prediction ROSE node provides the bird's-eye view of the surrounding of our vehicle with predicted trajectories. Ego vehicle appears in a blue box, while other actors are in red small boxes. The coordinate system is always centered on the ego vehicle so that the user can get a better understanding relevant to the current frame. The model gets hold of past 5 seconds tracking details of actors which appear in red lines and predict the trajectories for the next 3 seconds. The predicted trajectories appear in green lines. As future work, a dataset will be created for Sri Lankan context. However, our existing detection and tracking system performs quite well on dash camera footage recorded on Sri Lankan roads. As the community continues to advance on self-driving cars, the era of self-driving cars is just around the corner.